Yeah, start now?
No, you can just wait like 5 minutes. Put
Sure.
yourself on mute if you want.
Okay. And just introduce myself and get going at 10?
Yeah, about 10, maybe like 10:02.
Okay.
Yeah.
All right, let's get started. Okay, my name is Nick Lorenzen. I work for Northwell Health, a very large health system in the Northeast. Most of you probably heard of it if you're from the Long Island area or New York City area. I'm the director of engineering at Northwell Health, and I work on the innovation team. We are focused on building innovative solutions to real-world healthcare problems that we face on a day-to-day basis. I've been at Northwell for almost 9 years, close to 15 years of experience in software development. And today, the goal of today, I guess you could say, is to basically take your development skills to a new level. One thing I notice is that, and this is true for new developers. When I say new developers, are developers that are out of college or self-taught, whatever it may be, as well as seasoned developers that say join our team or that I interact with. They have a good understanding of how code works, right? How to write code. They understand algorithms and data structures. They may have an understanding of design patterns that, the gang of four design patterns and all that. But where things start to fall over is building and maintaining large scale applications, right? Shared applications where multiple people are working in the same code base. And also maintaining a cohesion in the code base so that the applications can be easily modified, understood. So if you're a new person coming into a code base, it's elegant, it can be easily read and understood and comprehended, and people can jump in. And you can modify it with ease and modify it without fear of breaking the whole system. I could tell you I've had many of night where I was up all night working on issues that there's a witching hour between 1 a.m. and like 4 a.m. that things tend to break for whatever reason. And a lot of it I've noticed in my life came down to just, poor practices, rushing, not really thinking through the design of the code and putting things together in a cohesive manner. And I got kind of tired of that. So I started, doing some more research on my own in my career to see how could I write better code, not just following design patterns, writing efficient code. That's extremely important. But how can I write better code, again, to make it more elegant? So that's what we're going to talk about today. This is generally a longer session than an hour, so I'm going to try to fit this into an hour. All of this code that you're seeing today has been uploaded to my GitHub, and I think that link has been shared on YouTube. The link is also down here for anybody that's looking at this can look this up. And I usually, we code in C#. That's our primary language. We also do some JavaScript, but I made this Python. This is a hacking kind of event. So, I'm sure Python's being heavily used. So I did this in Python as well, just it's more friendly for everybody. But we're gonna go through it. So a couple things on this one, right? Some people that I think, so today we're gonna really be talking about principles that were created from Robert C. Martin, AKA Uncle Bob. If you Google Uncle Bob, you will see tons and tons of blogs and resources. You'll also see amazing videos that Uncle Bob has created on YouTube that are all free, right? And this guy really cares about clean coding and cohesive design, right? And elegant design, and has lots of information out there for free. Martin Fowler is another important developer, architect, right, that cares about clean coding, has a business around it called ThoughtWorks. And overall, these two guys together really have a great set of resources to take your coding to another level, right, that we can't all cover here today. So I suggest you check those two guys out. Again, watching wise, so these two sections right here, I actually pulled from our onboarding docs, right? So anybody joining the team should be are basically asked to watch these things, right? So we have the Google Clean Coding Talks, which is excellent resources, right? Also Robert Martin's Solid Principles, basically what I'm kind of reiterating here in a little bit longer format. And then there's some reading, right? Clean coding. So Uncle Bob has a clean coding book that is readily available for anybody to read, right? That's out there. got design patterns and elements for reusable architecture. This is your Gang of Four book that many of you may have read in college or whatnot. Domain-driven design. This is a whole subject and topic about how you could structure your code around domain objects. 12-factor apps is a really important kind of concept about when you're building apps in the real world, even if they're startup apps or hackathon apps that turn into actual products, kind of what factors those apps should have. And then a really interesting book that recently came out is Designing Data-Intensive Applications for Martin Kleppman. These are, this book kind of takes modern approaches to like how we deal with a lot of data running through our systems, right? And then again, the repo for today's presentation is right here. So that's the intro. So let's get started. So we're gonna kind of, I'm mashing this together. So I'm gonna talk about SOLID. What is SOLID? It's an acronym for different principles, design principles. And then I'm gonna kind of segue it into overall clean coding concepts. Again, please research this on your own, right? And use this as a base to get that kind of thinking going, right? So, all right, so let's start with the S in SOLID. So pretty much every, I'm gonna call these slides, but they're really Python files, are gonna start with, breaking down SOLID. So the first concept, right, in SOLID is single responsibility principle. And this is a very important, all these are very important concepts. I'm gonna put a little highlighting on this one. So single responsibility principle is often abused and is extremely important. So a class or method should have one job and one job only, right? And before we jump into this, I put a little note here to train your eyes to look at the structure and setup first, then the implementation details. So this is also a thing I see with newer developers, less experienced developers, that they're very focused on how it works, like the implementation details. How does that method work? And kind of fall flat on looking at the whole code as a whole. So what we're going to do today is, you can look at how the methods are executing and whatnot, but going forward, try to think about how the code comes together, how the classes or methods interact to make a program work, right? That'll help you as you jump into new code bases, come up to speed quicker. So that's a kind of a extra bonus in here. But I say that now because you'll absorb more from the session if you're looking at at the higher level, as opposed to the implementation details. So the first example here, which violates single responsibility, is this text checker class. I, again, see this a lot, right? And we're not intending to do something wrong, but you've been asked to create a class or create a feature or something that checks some text from a file, right? And what we often do is we bind these two concepts together, when in reality, they're two different responsibilities, right? First responsibility is reading a file, right? And it could be also reading an HTTP request, it doesn't really matter, right? And then the next one is actually doing the business logic, right? Which is checking for text in that said file, right? So oftentimes it's easy, right? Just to put these together and stick it in your code, right? And in a small code base, not an end of the world, but as your code base expands and you want to reuse things, you start to have problems with that approach, right? It starts to create a lot of coupling and, makes this testing, we're going to talk about unit testing a little bit, makes testing this hard because this relies on a file system, right? So one of the things with single responsibility is breaking those things up into their own responsibility, right? So in this case, we simply took the read file method and we broke it into its own class. Now this could be used by anything, right? We could, anything that needs to read a file can now use this class. It has a single responsibility of just reading a file, right? And then we've taken text checker here, and you'll see I've appended an extra letter here because I hate lint errors. So that's just me being neurotic. But so if you see that, it's on purpose. But for text checker now just takes text, right? So we've broken these two apart. We've given them their own responsibilities. They are independent modules of each other, and they can function independently and be reused independently without concern of side effects or using something that doesn't really need to be used for that particular purpose, right? Like if you were, say, getting text from what I see would potentially be another violation is, say, you had to get data from a REST request, right? People would add a method here from a REST request, and you're continuously building this method up and turning it into what's called a God class, a class that does everything, right? And that makes your code base extraordinarily fragile. So again, I'm putting more highlight on the single responsibility principle, but it's the first principle, and it's an extraordinarily important principle. Have your classes, have your methods do one thing and one thing only. Okay. So we talked about single responsibility principle. Next one is open close principle, right? So you're extending your classes, but you're not modifying the implementation. This one is important because what I see a lot of times in code bases is an example of this discount. And you'll see this if you look and research open close principle. This is the quintessential example here, right? What you have is some discount object, and it's taking in a customer, right? And it's taking in a price and it's applying a discount. The problem with this class is that right now we have defined a regular and a senior discount, right? Let's say we want to apply a VIP discount, or we want to apply a Halloween discount, or we want to apply, today's Friday discount. Doesn't matter, right? You're constantly coming into this one class and adjusting it. Now, you might say that's not a big deal, right? But if by adjusting this class, and this class is used throughout the code base and in a large code base, you're making your code base fragile because you're opening yourself up for risk that if you make a typo, you have an issue, especially in a language like Python, which is not, it can be statically typed, but is not as strict as, say, Java or C#. You're modifying classes and potentially exposing your entire code base to massive bugs. Right? So it is easy to add another if statement here for a specific situation, but it's not necessarily the right way or the safe way. Another option, right, would be to basically build a discount class. You could call this a base class if you want, right, that does the standard level discount, right? And then from there, so this would be your regular discount, right? And then from there, you can inherit it and do a senior discount, right? We're doing the same thing as regular in here, but now we have a separate class that will call the super, right? Calling the discount class and performing an additional operation on that data. So you're extending it, but you're not necessarily overriding it or modifying the underlying class. This class right here, discount 2, is closed. It's open for extension, but it is closed for modification. It is defined and you are not going to redefine it. You will just continue to extend it safely in your additional use cases and use it throughout your code in a safe manner. So that's open close principle. All right. The next, so we've done single responsibility, open close principle. Next is Liskov's substitution principle. This one often gets misinterpreted, kind of devalued, and I'll kind of explain why that goes in there. So basically a subclass must be appropriate for the superclass. If it looks, and there's a quote that kind of goes around, it's actually a meme. If it looks like a duck, quacks like a duck, but needs batteries, you have the wrong abstraction, right? What does that mean? Basically, and we do this a lot, and I think it's a human nature kind of thing where we try to draw similarities between things that are not necessarily similar. And as a result, we end up trying to fit that circle in a square hole because it seems right, but it's not necessarily the right implementation. So being that I work in healthcare, I use a doctor example here, right? So let's say in our program, we're defining a doctor class, right? And in this doctor class, we pass in the constructor an NPI ID. What is an NPI ID? This is basically a national provider identifier. It would be like social security number for that doctor. It identifies the doctor in the United States, right? So every doctor gets one of these, right? So it's inherent if we instantiate this class that we should have an MPI ID. If you're a practicing doctor, you have it, right? And we have a method that says get MPI ID, right? And then we've defined a method here because some doctors perform surgery, right? And when we define our plastic surgeon class, which is going to extend doctor, because of course a plastic surgeon does have an MPI ID, the perform surgery class, or perform surgery method, makes absolute sense, right? Because it's a plastic surgeon. They're going to perform a surgery. What kind of surgery? You can start getting into a debate with that, but they're definitely performing surgery. Now, where that starts to break down and you start to violate Liskov substitute principle is now we apply that to a radiologist class, right? So we have to make another class. We get a use case. Well, your program now has to accommodate radiologists. And a radiologist does X, Y, and Z, and you'll implement those methods. But when you extend doctor, yes, you do get the MPI ID, which is great. But where you begin to fall over is now you have this class, this method here, perform surgery. Well, that's just not part of this radiologist's task. So you're inheriting a class that doesn't necessarily correlate to what you're trying to achieve. And yes, you could do it and just not do the perform surgery method, but you start running into problems down the line in your code base as you pass these objects along, where you're now having to check what type of object this is. Is this a you can't trust the doctor object, right? You say, is this did I pass in a radiologist object? Is this a instance of a radiologist object so that I know that I can, perform a method that's specific to the radiologist? Or is this an instance of the plastic surgeon object so that I can do the perform surgery? Because if I don't check the instance, then I could call the wrong method, right? And that's where you're running into trouble. That's a code smell that you must look out for, right? So a simple solution to this, right, is to break out that perform surgery. That is specific to a surgeon class, right? This is the stacking of your classes within your program or your objects within your program. So in the doctor class, we've removed the perform surgery. It's too specific, right, to a certain implementation or a certain type of object. However, we know, again, that all doctors need to have NPI. So we've simplified this doctor class and said, you're just going to pass in an MPI, and we know all doctors have to have it, and that's okay, right? And then what we've defined is a surgeon class that will accept a doctor class. And that surgeon will be able to perform surgery, right? And then when we have our specific implementations, because not all surgeons are the same, right? You have heart surgeons, plastic surgeons, orthopedics, right, that do surgery and all the things. So basically you can define your plastic surgeon class now, accepting in the surgeon, right, which is also a part of doctor, so that you will now get still the MPI ability, but also the perform surgery ability. And now for a radiologist, it's extending doctor because we need the MPI ability, but it no longer has that need to perform surgery, which it didn't make sense to begin with, right? So again, what we're doing here is we are making appropriate higher level abstractions for our subclasses to inherit, right? If it looks like a duck, it quacks like a duck, but needs batteries, you probably have the wrong exception, right? You can have a real life duck and you can have a battery powered duck. There are two different higher level classes, and you should really think in your head how you're breaking those classes out appropriately, right? This one takes practice. So continue to research on this one. And it takes a bit of thought up front, and sometimes you don't realize up front the different layers of abstractions or the different methodologies, and you're going back and refactoring, and that's okay. And this one takes practice, let's put it that way. All right. So we did single responsibility principle, open close principle. We just talked about list-offs. Now we're doing interface separation principle. So we're making fine-grained interfaces that are client specific. Avoid big interfaces. So what's an interface? An interface is essentially higher level, a contract, right? And in Python, you don't really have a concept of an interface. You can call a class an interface. It's not really an interface. It's more of a Java or a C# kind of thing, C++ kind of thing, where you actually have a type of object that is considered an interface, where there's no implementation details. It's just a contract between you and some other code that's going to use it, right? Well, so what is this contract? It's a deal, right? It's saying if you implement me, you have to implement these methods so that as they get used, and which they may get used differently, right? That's okay, but high level, these methods have to be defined. So this one is one that I have seen over my year constantly get messed up, right? It's easy to do this, right? So, and this is an example, a slimmed down real world example, right? So I've seen in a class, basically, or an interface that we defined, somebody defined a parser, right? And in this interface, right, they defined 3 methods: parse HTML, parse JSON, and parse text. And you may be parsing it to the same type of object, but obviously you get, different HTML in, you get different JSON in, you get different text in, but you may be slimming it down to the same type of normalized output, right? It doesn't really matter. That's the point of an interface, right? You can implement it throughout your code base as needed, depending on what's happening, right? But here's where the problem comes in, is that you have 3 different types of inputs that you're putting in here, and you may not need to use them in all cases. I may have a use case, right, that says you're going to get an HTML file from some endpoint, right? You're making a REST call, and then you're going to parse it to, pull out some information, right? Some patient information. Maybe you're looking for ED, looking for emergency department wait times, and you're going to get that HTML in and parse it out and then present it in your application, right? Or maybe that has for one hospital, hospital 1, they have an HTML page, right? And that's what they have that you're parsing through, right? You're using Beautiful Soup and a Python package to parse through the HTML and get out the ED times. Other example is another hospital has an HTTP client, right? A REST endpoint where you can actually get structured JSON that has ED wait times in it, right? And then in another hospital, you may be just getting a text file. It may be FTP to you. It doesn't really matter, right? You got these text files. So you have these different implementations, and as you're using them throughout your code base, you're defining them in this class and passing this class around, and you may or may not need to use them, right? So you're kind of violating, in a way, this is violating also single responsibility, right? But you may also have other new hospitals that come, and you're using this class, right? You're implementing this class, but they only have text, right? So you're not really defining these. Well, it's risky. It's obviously defining single responsibility principle, but it's also exposing yourself for issues when you don't implement and somebody accidentally calls the method and gets an error, right? So interface separation principle suggests simply that you break out your parser, right? Or you make it higher level or more generic, right? So I have the I parser here, right? That has a method that's defined parse. And then what I can do is make implementations of that parser as needed, right? That can or cannot be reused potentially, right? So I may have an HTML parser here, right? And JSON parser, text parser. They are all implementing the parse method, right? In their own specific way. Now, I didn't implement the logic because that would be depending on your use case. But the point being is that I've broken these out. I've created a very generic, fine-grained interface that each one of these classes will inherit, and then you as a user of that interface, whether you've defined it or you are coming into a code base and saying, all right, well, I have a new hospital, they're getting text, I need to do something special with that text. So therefore, I'm going to write my own method here, right? So we have, like, Long Island Jewish Hospital, right, on Long Island. I might have an LIJ text parser, right? And it has its own logic, but I know that there's only a parse method here, right? And I know I need to implement that method with my own logic. And if I'm using that in another place, somebody else picks that up, they know that you've already implemented the parse. These are very fine-grained interfaces rather than stacking them all into one, right? So that's interface separation principle. Again, fine-grained interfaces. I see this one violated a lot, especially when it comes to database connections. So if you have a class that does database connection or database queries, I often see, which I did not highlight here, but I often see you'll have one class for the entire database, right? That class is getting users out. That class is getting accounts out. That class is getting, if we're looking at like say a blogging example, you'll have, this is highly anti-pattern, right? You'll have, class, DB class. It'll be something very generic like this that everybody will use, right? And it'll start off as an interface. So you'll start out with I, and then, which is good. A database class should be an interface, and I'll explain why once we get to the letter D in solid. And you'll have different methods here like get users, right? Which is pretty common, right? And then we'll put pass right here. We'll bring this one over. And we'll do self there. And then you'll have get one user, right? Pretty common, right? Single get user. And then where stuff starts to get away from it, right? Because you're still implementing this class, right? This is just an interface. Where stuff starts to get away is then you'll also have like get accounts, which again this ties very nicely into single responsibility. So you still want the interface, but now you're expanding your interface out into a bunch of different things. So this is in a sense single responsibility principle for interfaces, right? And again, I'll explain in the next one why this is important. So again, keep your interfaces fine-grained. Let the user, which may be a colleague or a teammate or somebody else that's forking your code or using it as a library, let them define the interface as needed, right? Cool. So that's interface separation principle. So let's go to the last of the solid, right? Dependency inversion principle. Inject Yode dependencies, right? So at first when you look at this, and when I first saw this, I didn't really understand what dependency inversion, what I'm inverting my dependency, what does that really mean, right? And really what it boils down to is dependency injection, right? And why is that important, or what does that mean? Well, so you may have dependencies on other classes. You may have a class that, so let's go back to even single responsibility principle, right? We already talked about that we should split up classes, right, into their own responsibilities. And that's a good thing. But at some point in your code base, you may need to bring together modules that they themselves have their own responsibility. And those modules, which in this case are classes, right, essentially bring together or orchestrate between other modules, right? At some point in your program, you have to bring this together. And it may be lower in the code base, it may be higher, right? You have a main method that's going to kick off your code, right? So you're bringing together these single responsibility classes. And within those classes, some of them may or may not have side effects. So what's a side effect, right? So a side effect is essentially something that's out of your control, or in other words, is not pure. So what does that mean? Well, in many of our programs, especially if you want your program to do something interesting, right? You potentially need to call a REST API. You potentially need to call a database, SQL Server or MySQL. It doesn't really matter. NoSQL database. You need to call some type Firebase. You need to call some type of database, or you may need to read a file. Right? You may have a configuration file in your program. You may have some JSON file that you do formatting on. It doesn't really matter. You need to do something that has some type of unexpected consequence, right? Because with a REST API or a database call or a file, the table may not exist. The file may not exist. There may be file latency, right? Something happens with the machine you're running on. The REST API is down. The REST API is slow. Time's out. The REST API doesn't return what you expect. There are external dependencies or dependencies with side effects that can throw off your program, right? These things are also extremely difficult to test. So again, I'm going to talk about unit testing as the last module, and we should be unit testing. But let's say you wanted to write a test against your code to validate that it's working. It's doing some very complex business logic, right? And that business logic is considered a pure function. What's a pure function? A pure function is that you have a deterministic output for any input, right? If you're adding two numbers, right, and the numbers are, 2 plus 2, you're going to get 4, right? That's a pure function. However, if you're calling a REST API, that's no longer a pure function, especially if that REST API is calculating the two numbers for you. Yes, 99.9999% of the time you may get back 4. However, there may be a network issue. The service may be down, and it loses its purity. So if we look at these two classes here, right? Even though this is a wrong example, I'm going to show you why. The good thing is we have performed single responsibility principle, right? We've broken these two out into their own respective classes that do certain things that we can reuse. Fantastic. However, and we've isolated, which you should always do, those unpure things, those non-deterministic calls, right, to open a file. We've isolated it to this one class, this one method. There's no logic in here. There's no specific logic other than just give me file data. This is a good pattern to do, right? However, when we have our main class, which is going to bring these together, and main doesn't have to necessarily be main. This could be a service class, a handler class. It could be various things, right? What we're doing here, though, is we are defining these in our code base. We are instantiating these classes within the run method, and we are making this run method extremely fragile. Why? Well, this is going to make it nearly impossible to unit test. And again, we'll talk about unit testing in a little bit. But if I wanted to run a test against this main class, right, I'm in trouble because this file may or may not exist in my implementation, right? Especially when it comes to databases. You may not have the data at hand on your local system or in a test environment that you're expecting in a production environment, right? Or the API may not be available. You may not even be able to call the API due to security limitations, right? You could call in healthcare, we have a lot of restrictions against patient information. You may only have access to the dev environment, and oftentimes those environments are not great, right? So you've just made a hard instantiation here, right? Now, text checker, this is not impossible to test. It's not so bad. This is a pure function, right? It's very deterministic. The problem, though, is let's say you wanted to change the implementation of text checker, or you had a interface here, right? Class I text check, right? And you wanted to create a new subclass because you didn't like this implementation, or your implementation or use case, somebody came to you and said, hey, this has got to change, right? By instantiating this here, you're saying, I'm only using this class, which means you have to go back in and change this class, which is very risky because others may be using it. And in large code bases, you may be breaking other people's code that they wrote, other use cases. You may unintentionally change something that you're not really realizing, but it broke a feature that people really rely on in your application just because you're doing the right thing by not duplicating these classes, right? So you're defining hard dependencies here that make it very difficult to test. So what can we do about this? Well, we can inject yo dependencies, right? In this particular class depends on these two dependencies, file reader and text checker, right? The implementation has not changed, right? And again, you can use types in Python, right? But interfaces are not really hard and fast. When you get into, say, C# and Java, these are much more stricter, right? So you could, create a whole new text checker class, right? That is text checker with something else, right? Terrible name. And you could still when you test this class, you could test this class down here, right? You could say main equals main, and then you could pass in the same, file reader, and you could pass in text checker with something else, right? Doesn't really matter. Or you could swap it back out for this one, right? And it doesn't really matter. It's just executing that class, right? Again, you probably want to have an interface here because these methods should exist. But this gives you flexibility. And again, will make more sense when we start doing some unit testing. You're configuring your classes with the dependencies and you're using the dependencies within the class, but you're not instantiating those dependencies, which make your code very fragile. Great. So we've rounded out solid, right? And again, please research these. There's way more depth to these than what I'm explaining. So the next thing I'm going to do, and this is kind of Uncle Bob's book of clean coding, is kind of go over some right and wrong or gotchas or whatnot. Some things, again, when you're dealing in large code bases, again, you guys, most of you are doing a hackathon right now and you're writing really hard, fast code and all of that. But as you get into larger code bases with many people, these are good principles to follow, right? To make sure that you're a good citizen in the code base. So one thing is be descriptive with complex logic and hide it in objects. Most of the languages that we have is object-oriented programming languages, right? And we often violate those principles. And I don't think it's intentional, it's just easy to violate them, right? So we're descriptive with complex logic, and we're also hiding information in our objects, right? So in this particular case, right, we have a class patient, and I didn't implement what has cough and is sneezing and is vomiting means, right? But these are three methods that potentially have logic based on condition or data that's passed into this patient class, right? And then in our other parts of our program, we implement it by calling on patient, and we probably pass some data in here, right? And then I often see this where in this other class that has nothing, that is interacting with the patient, it's doing some logic, right? Now, if you wrote this, you understand it, right? But if somebody didn't write it, they come into this. This is a pretty trivial example, but I've seen cases where it goes way beyond this. They're coming into this code base that knows that this may be interacting with 10 different objects, patient being one of them, and they hit this and they have to really think about what the heck is going on here, right? I've also seen and been guilty of this myself. I wrote this, come back 3 months later and forget how it works. And I may introduce a bug, right? So the right way or the right situation here would be to still have your class patient, right? But define a method that is descriptive in saying is sick, right? This is not super descriptive, but it's descriptive enough to say the patient's sick. These conditions themselves constitute sickness, right? And this is a helper method to kind of put together and hide away, abstract away, right? That complex logic, so that when I'm using it throughout the code base, I'm just calling is sick, right? I've simplified the lines of code and I've hidden away. And if I really want to go and see what is sick means, I can. It's fine. It's not a problem. But if I'm debugging another part of the code that may have other lines, and again, working with 10 other objects, I know what this means is sick. So again, we are trying to be descriptive and avoiding leaky abstractions, leaking out this logic which should be hidden in this class. I actually started at the bottom. Sorry, apologies for that. So it doesn't really matter. These are all extremely important. So classes and methods should remain small and do one job. Again, this is a single responsibility principle. I'm expanding on that. You'll hear that principle said over and over again. It's highly violated, right? Keep your methods under 20 lines of code. Any more and you're probably breaking single responsibility principle. In methods, it's extremely easy to do more than one thing. Sometimes we unconsciously think about that, right? So keep it elegant, let the code speak for itself and not the comment speaking for the code. I'm not a big commenter. I'm commenting here in this code base, but those that work with me know that I don't write comments. And then the reason why I don't write comments is because the code should speak for itself. If I'm not being descriptive, if I'm just having a method here that's like X equals, some method, some class, right? And then X do stuff. This is terrible. You need comments for that. But if the classes are small and you're following solid principles and you're being descriptive and expressive, you don't need it. You don't need a ton of comments. Maybe you use comments when you're doing some really fancy algorithm that you're implementing a skip list or some type of reverse list or linked list, whatever it may be, to kind of help the reader of the code understand it. But really, you don't need that. You should be expressive through the code itself. It's text itself, right? So in these particular cases, you'll see that the methods are small and simple. Again, I'm reusing this one over again. We know this is a file reader. We can get text from a file, right? And we know this is a text checker. It's a trivial example, and we're looking for contains checks, right? Another thing that I see highly violated is that so methods shouldn't exceed 3 input parameters. It makes them more confusing, fragile, easy to break, especially easy to break, right? If you need more input parameters, consider passing an object. Again, we have sometimes this fixation on primitives and we forget about objects even though we work in an object-oriented programming. So I see this a lot, unfortunately, which is perform input descriptive task, right? So this is, it could be anything, right? And it's passed into it are 5, maybe more. You see the k-args and Python, but you'll see 5, maybe more parameters passed in, right? And in a language like Python, especially if you're not using the, which I didn't hear, right? You're using the type constraints. You don't know sometimes if it's a dict, if it's a list, if it's what, a string, a bool, an integer, you don't really know. So you're making a really fragile method here. Additionally, no code in a real code base is ever immune to change, right? So you're going to get somebody that potentially asks you to make a change. And if you make that change by adding a new parameter, you could potentially break all others that define this method. And if it's a good method, it'll be reused a lot throughout the code base, right, potentially. So you're looking to break it. And, somebody comes in and removes a parameter, oh, I'm refactoring, it doesn't really need that. No, you're breaking that, right? So there's a lot of fragility that's added when you have a lot of parameters. In this particular case, I hid those parameters in a config object, right? And I can, instead of having these 5, I pass in an object. And all of a sudden, things get a little bit easier, right? Things get a little bit cleaner in the sense that you have an object that defines your parameters. They're hidden in a class. You're using object-oriented principles. You can expand on this. You still could have problems if you take away a parameter, right? But you're no longer having to change the method signatures. You're just changing the logic, the details, right? So don't forget to use your objects, and especially when you have lots of parameters. This is highly abused, and it's just have an object, just pass objects around. You can add to these objects really easy. Like I can add a new param here. And if my other classes, right, are not using them, say I've defined this method, or I use this method in 100 different classes. if I add this new param here and I only need it used in a certain cases, I'm not necessarily breaking everybody else, right? If I'm passing in this config object around to different methods. So think about that, right? It's just making your code more cohesive and less tightly coupled. All right, so that's some coding styles, right? I'm going to talk briefly about failing fast, right? We all know our exception handling, right? So fail fast, don't send error messages. If you're working in the language of Golang, it is error message. It is using status messages. You can't get around that, right? But in this particular case, you see we have the get text from file. I put a try catch in here, and then in my code, I have to go and actually check, did I get text back, right? When in reality, I let the file reader fail. It may fail because the file's not there, file's locked, some odd situation, right? I let this class fail. And in other parts of my code, I decide, well, this failed fast and I'm gonna do something about it, right? Or I may not, it depends. The exception to this rule is if you needed this to be, so what you want your code to do is stop when there's an error, or stop at a point higher level where somebody can be notified or it can be logged or whatnot, so that it's not this cascading failure, right? The exception to this is if you need the program to keep going despite the failure. There are cases where you may or may not care. It fails and you keep going. Then in this particular case, failing fast is not important. You would just hide the error, potentially log it, keep going about your day. But if you need to fail because something's not there, fail fast. Don't hide it and then try to remember to look for it, those situations in the higher level code that's implementing, that's using this or calling this, instantiating this, right? Another one that I see a lot, and that is unfortunate. If you look back at the one interesting topic is the history of nulls and how when the null was introduced, it was a very big blunder, right? This is usually a big reason why our code fails is null handling, right? We're not handling nulls appropriately. That could be based on because we are passing in nulls or giving back nulls. Right? Classic example is, get users from DB. This could potentially return a none in your code base, depending on the library that you implement. If you implement like an object relational mapper library or whatnot, or you're running SQL or whatever you may be doing, you potentially could return a null. So then in the higher method, right, the method that actually calls this get users from DB, right, you have to make sure that you remember before you iterate on users to check if users are there. Now, maybe 7 out of 10 times, right? People remember that, but usually they don't. And sometimes, in the test environments, you always have the users there, right? May not be the normal way users are represented, it's test users, but then you get into a production environment and all bets are off, right? And you get this error real quick. You're like, oh, I forgot to add it. So being a good citizen would be, all right, you're expecting a list of users coming back. Great. Let me get that users from the DB. If it's null, I'll check it in this method, and then I'll just return back an empty list. And then in this method, I may get back an empty list, which may not be ideal, but at least I'm not throwing an exception. So what the result of this is, like, let's say you had a web app, right? In a web app, you get the null exception, it shuts down the web app, right? Or it throws an angry message, exception message up on your web page saying, well, you got a none exception, right? But let's say you just passed an empty list back. Well, maybe on the page that displays users, it's empty. You're like, well, why is it empty? That's weird. But it's not throwing the exception, right? In larger scale applications, it may be odd for a user to see, and the user themselves might open a bug and say, hey, this list is empty. And there may be a problem there, but it's much better than giving them an exception back. So watch your nulls. Be a good citizen. Don't give somebody a none or a null. Give them back an empty object. This is a design pattern too, that the null object pattern, right, in your Gang of 4. You can read much more about it, right? All right, cool. So let's let's look at the last module here. So testing, right? So if you download this or fork or clone or whatever, this particular library, the only dependency this has is PyTest. PyTest is a testing library. It's a little bit better than the standard issue that comes in Python, right? And what this will allow you to do is like test your code, right? You should be testing your code. I can spend days talking about unit testing and the practice. By unit testing, by making your code unit testable, what you're doing is you're ensuring that the code is wrote in a certain way that makes it testable, right? I know that sounds a little funny, but you have to separate your business logic from your database and your network calls in order to properly test it. Like I showed in the previous example, we're going to see down here, right? You have to modularize your code more effectively so you could test chunks of it much easier, right? So we're going to attempt to test how your code behaves with unit tests, test passing, and failure situations. So again, what I see a lot of developers do when they first start unit testing is they test the first situation. So we have a string to list right here, and the first thing that they do is they test. And I'm very descriptive in my tests, and you should too, right? Test when comma separated string is given, then a list with 2 items are returned, right? This is a passing scenario, right? Or this is a positive scenario, right? But you should also test scenarios, right, where this may or may not work well, right? So in this case, I'm testing hello, comma, world, right? What happens if I pass in a blank string? What happens when I pass in a null? These are failure scenarios that you should consider, right? Most time when people start testing, the first thing they're guilty of is they write one method that just validates that what they're, in this very trivial case, they validate, yeah, this works, great, move on to the next thing. That's fine. But let's say you're getting this data from a file or a REST API or something else, right? And it's not present. Either it's null, or it's blank. Will your method be able to handle those weird situations, right? So let me just pull up, I already have console up here. So I'm just gonna run a simple method here, PyTest. And we saw that it ran very quickly, right? And it found 4 items because I prefixed them. The only reason this is out of order is because you need to prefix your classes with test. And PyTest goes and looks at your code and says, oh, this is a test class, great. Oh, this is a test method, great, I'm gonna execute it in this runtime. And you can get more detailed observations and whatnot. So in this particular case, I can handle a normal situation, right? I can handle a blank situation. And I know that if I pass in a none to this, I'm going to get an exception. And that's okay. I'm fine with that, right? Let's see a case, right? This is an example of what a failing test would look like. This is test null, string returns a length of 0. Actually, it returns the case of 1, sorry. So, and this should be, my apologies, return. This one would be throws on error, right? We know this is not going to return a case of 1. It's going to fail. So let's run PyTest, right? Oh, and we got a bunch of red, right? So let's take a look at this, right? So we see that we collected 5 items, right? And we got a failure. And if you get 1 failure, it's all failed. I mean, even though you have 4 pass, great, you got a failure, and it's going to tell us why it failed, right? And it's basically saying, well, this is a none type, and you can't split a none type. You can split a string, but you can't split a none type. So fix it, right? So this gives you good feedback and lets you validate your code against different situations. And then the last thing I want to show here, right, is again kind of going back to that single responsibility principle. It's using the S, single responsibility principle, but also the D, the dependency injection, right? So it's refer back to dependency injection. Separate your logic from the network calls, right? So that it makes easier to test, right? You don't need to test. You can test. You don't need to unit test a network call. You can have integration testing. You can look at the testing pyramid, right, which has unit test at the bottom, which is checking your code, functional checking test, which is kind of checking your code base at a higher level, and then integration testing, which is testing your whole application end to end. You could do all of that, right? And I suggest you do, right? But at a unit test level, where most developers start off, you don't need to test the actual network call. More than likely, it's not going to work. It's going to result in slow tests, flaky tests. Flaky tests meaning sometimes they work, sometimes they don't. Slow meaning, calling a bunch of REST calls is extraordinarily slow. So in this case, we're using a mock, right? And you can learn about mocks. I suggest you learn about mocking, especially if you're in, it's very easy to self-mock in Python and dynamic languages. You need more libraries in like C# and Java. In this particular case with the mock object, I'm pretending to be this file reader, right? I could create an interface for this, but it doesn't really matter in Python. I'm passing in some mock data, right? I'm implementing the same rule here, right? The same method, right? Get text from file. And I'm just returning back the mock data because I don't want to test this. I just want this I want this class to be easy to use in my overall program. Now, in the text checker, this is a pure function. This again has no network dependencies. So I don't need to mock this out. I want to actually test this business logic. I want to make sure that this business logic works on whatever I put in. Right? So I have my program here, right? And I'm using dependency injection, right? So I've used solid and I've used the dependency injection and I'm passing in file reader in the text checker, right? I can have different implementations of text checker, it doesn't really matter. And then I'm bringing together those two classes to put an output out, to run, right? To make an output. So what happens by doing the dependency injection and also having the single responsibility principle, I've made this class very easy to test, right? So I can pass in my hello world, right? In my file reader mock in my test class here. And then I can I can instantiate the text checker and I can pass that into my program, almost like config objects, right? And then I can assert that everything works as expected. Because again, I'm not trying to test that the file exists on the file system. I know that the text may look like this. It may look like a lot of different things, doesn't really matter. I'm testing, does this method work within this program? If everything else is equal, right? The file exists, right? If the file doesn't exist, the program's not gonna run. If the file exists, that's implied, right? But I really wanna test that this class works well so that when I implement this class, in my program, or it's a module within programs, however you implement it, if I pass in a real file reader, I know that's going to work, right? Because it's not obviously throwing any like lint errors, right? And if it doesn't, I can have integration tests, right? But the contract exists. I can test to make sure that everything in this program class is working together. I'm validating that text checker works and that it's all coming together as expected with their unit test. So it comes together nicely, right? And again, if I run the PyTest, you see that it ran without any issues, right? And if it didn't, for whatever reason, it would come back and tell me I had a problem. So unit testing is extremely important. It's a deep topic. And also, we get pressure not to do this. So my biggest suggestion if you're doing unit testing is practice unit testing. And when you're doing your code, when you're writing your code, especially in a setting where you may be working in a company or enterprise, factor your estimates when you estimate your code. Add in the unit testing portion to those estimates so that you can actually be a good citizen in the code base and test appropriately, right? Don't wait till the end to write your unit tests. Write your unit test as you're writing code, each part, so that if you wait to the end, most developers to say, oh, I don't have enough time, or I think it works, and it could be riddled with bugs. The unit tests are there to help you check for bugs, but they also help you format your code in a way that's very modular, that's very separated from side effects, from logic from side effects code, and it also makes it easier for other developers coming in to look and say, hey, what is going on here? I can run the unit tests and see how the code's interacting. And in a large code base, that's extremely helpful. So that's all 8. of the different modules that I wanted to go through. I know that was a lot in 1 hour. Again, I think the link has been posted for the GitHub. It is out here, solid clean coding. You can download this, take a look at it, run it, give me issues. I may not respond extremely quickly, but input is great. Also to take a look at the intro section again. There's lots of reading, right? We never stop learning as developers. You can always hone. We are craftsmen of code, craftsmanship, or craftsmen and women of code. Be mindful of the code that you write, because it's oftentimes used in important situations, healthcare, fintech, money, patients, lives, things like that. It's your duty to write good, clean code and be a good citizen in the code base and hone your skills in. So continuously learn how to write good code. So thank you for your time and have a great day.